show we have Katrin Monecke, who is a professor of geoscience at Wellesley College. She's a graduate of the Department of Earth Sciences from the Swiss Federal Institute of Technology in Zurich, Switzerland, and her research interests include beach ridge formation and coastal progradation in northern Sumatra, and the sedimentary characteristics of prehistoric tsunamis or tidal waves in northern Sumatra in Indonesia and Thailand, as well as studying hurricane deposits from Hurricane Katrina. Katrin has also worked on assessing earthquake hazard assessments and studying ancient earthquakes from lake deposits and landslides in high mountain areas and stream deposits in Nepal. So it's a very exciting research and work. Welcome, Katrin, to the show.
Thank you very much, Rama.
So excited to have a professor of geosciences here finally on the show. And a woman on top of that, so it's awesome for us.
Thank you. Thank you for inviting me.
And I hear that you've had a very exciting summer, so tell us where you went.
Well, early in this summer, I actually went to Sumatra, back to Sumatra, because we're still studying the growth of the coastline since the 2004 tsunami. So, and I took a student with me from Wellesley College, so it was for both of us a very exciting experience. And now, just a week ago, I came back from the Netherlands. So we work with coastal modelers on our data from Sumatra, and basically try to model the coastal processes and understand why the coastline grows in a way that it grows in Sumatra.
So, and this is a university in the Netherlands? Where you
Yes, this is the Technical University in Delft.
Oh, nice. So you go there and you have the lab there to analyze some of your data and take a look at what you found?
Well, it's more kind of a collaboration, so we just started this, so it's just looking into their computer models that they have to analyze coastal processes.
That's exciting. So what did you find? What's going on with the coastal processes?
Yeah, well, we are a little bit surprised. So the coastline was completely destroyed after the 2004 tsunami. So, and then it grew back very quickly. So we were surprised how quickly it actually came back. And but in the most recent years, we have seen that the coastline is actually losing a little bit again, and this is something that we don't really understand. So, and so this is where the coastal models come into play. And
so if it weren't for the tsunami, how fast would a coastline build up? For
and
instance, in that region of the world?
So in that region, it's actually surprisingly large. So it's about 1 meter per year that we calculated there.
Nice.
So it's very quick. So a yard per year.
Yeah, a yard per year, and a meter per year.
Yeah.
So, and then what is the natural erosion rate? Is it about a few inches every year, or?
Yeah, so right now, so over the last 2 years, we surveyed that it actually receded by 40 meters. So that is
that's quite a chunk.
Yeah, this is quite a chunk of coastline that is lost again, and we don't really understand it.
So you're not sure if it's because of the tsunami or the after effects, or if it's just natural?
Yeah.
If the patterns are changing?
Yeah, it's probably a very complicated interaction of the ground movement of the earth, then about sediment that comes to the coastline, the wave parameters, the tidal parameters. So it's all kind of coming together and shaping this coastline.
Fascinating. And does that have any implications for the American coastline?
On
a global scale?
Yeah, so, well, the more we understand how coastline react to extreme events, so for example, in North America, you would have hurricanes along the Gulf Coast, for example, so it would be transferable to that coastline, and to understand how coastline react to these extreme events like tsunamis or storm events.
Which is very important and exciting and useful information for all of us who live here.
Yeah.
Absolutely. So I wanted to ask you a question, going back a little bit. So I wanted to ask you, why geology? Of all the different sciences that you could have chosen from.
So yeah, geology, I was always fascinated by traveling to foreign countries. So when I finished my high school, I wanted to do something where I could explore the world. And so there was geology or geography, and then geology just incorporated the natural sciences a little more. So, and then it was actually my father who said, oh, geology is a little bit more concrete, just do geology. And I never felt bad about it.
I was afraid that you might be just backpacking endlessly, just in different places. studying the geography of,
yeah,
of the world instead.
Yeah,
That's
exactly.
too funny. And where did you go to high school?
So this was in northern Germany. So I did all my high school at
there.
one.
And they had a good geology program.
Well, they actually, earth sciences were touched just a little bit. And so, I didn't know too much about how geology would really look like. So, but then I discovered it.
So interesting. And I know you mentioned that your husband is American.
Yes.
And did you come to the U.S. Before you got married?
Yes.
You did.
Yeah.
So what drew you to this part of the world before settling here?
It was basically that I got to know my husband in Europe, and then it was just easier for me to travel to the U.S.
And is he a geologist as well?
No, no.
Well, that's okay. We'll forgive him.
Yeah, that is true.
Excellent. So I wanted to ask you, do you find a lot of women in the geosciences in your classes and these days when you go to conferences? Compared to maybe 20 years ago? Yeah,
I think that there has been definitely a change. So when I started to study, I was actually the only woman in my year. So it was always funny when you went on field trips and then you are the only female, so you get your own room and everything. And so
it's actually better. It worked out better for you. You get your own spot to yourself. You don't have to share with anyone.
That is true.
It worked out well.
Yeah, in a way, this is true. And well, now what I see at institutions is that it's probably half-half, and I think this is very good.
Yeah, and did you ever feel discouraged that you're the only female in a science world at times?
No, not really. That so it was really, I was so interested in the subject, and I had very good fellow students, so we really enjoyed studying that field.
Excellent. So so tell me about this bag of sediment that you brought us today.
Yeah, well, I just brought this just to show you how this might look like. So what we are,
I'm gonna hold this up.
Yeah, what we tried to find.
Look at that.
Basically, so the overarching theme of my research is to find traces of earthquakes and tsunamis in the geologic record. And this is, for example, this sand that comes from the 2004 tsunami that was deposited in the coastline in northern Sumatra.
So these are Indonesian coastal sediments.
Exactly, and specifically from the tsunami. So the tsunami deposited a thick sand layer in the coastal marshes. And this is what we sampled, and we analyzed this and determined the grain size and learn a little bit more about the flow parameters.
And where do you think this is from? You think this is from the middle of the ocean or more
probably
closer to shore?
Yeah, closer to shore. It's probably from the near shore environment, so maybe like 300, 400, 500 meter out into the ocean. This is where the wave really touched the ground.
Hits the shore and then scrapes dirt up from right where it breaks at the shore.
Exactly.
Interesting. So tell us about some of your more memorable experiences in the field.
In the field,
tell us some stories.
Yeah, probably. So I guess this is the doing field work in foreign countries are probably my most memorable experiences. So when I went out and did my master's thesis in this was still with the University of Hanover in Germany. I went to Nepal and we studied landslides in high mountain areas. So, and it was just so our advisor, he brought a fellow student of mine and myself. He brought us to these foothills of the Himalayas, and then he said, "Okay, now find this out." And then for 3 months we were on our own and basically investigated the area, mapped these huge landslides, and that was a very remarkable experience for me.
Yeah, I'm sure, and it's very pretty as well.
It was a very, of course, very exciting landscape. So the Himalayas were just very impressive.
And did you study erosion processes there as well? And
so in the way that these landslides basically bring material into the valleys, and they can be pretty large and actually cover whole valleys. And this is what we wanted to understand a little better.
And what were some of your interesting findings from that research?
So mainly that so these landslides can be huge, so they can really cover whole valleys. And
so the town of Wellesley would be covered in one landslide, for example.
And even though in
so
that area,
in
that area it was not so densely settled, so there were not so many people there. But still, there were a few villages, and they could have been highly affected if one of these landslides would have happened.
And do you think that's because of global climate change? That we're still not, we haven't, in America, I don't think we've come to a consensus whether or not climate change is really occurring. So I think that's still on the fence. But if it were, do you think it's because the global climate is changing?
Well, that might play a role in this whole story, but it's also this very steep relief environment, so the slopes are just unstable there, and you have a lot of material on very unstable slopes, and if there's an earthquake or you have maybe a snow melt event or so, then you can mobilize
because
this
there is a lot of seismic activity, and the mountains are still rising.
Exactly, yeah.
So
that's exactly it. So it's just a very dynamic environment.
Area.
So
that's interesting. Wow, that's great.
Yeah,
that's so exciting. So let me ask you about the American women's movement that I tend to ask a lot of my female guests on the show, because it's just interesting that we've hit the 50th anniversary of the movement, and I just wanted to know what your thoughts were, and if you ever thought about it before you came, or now that you are here, if it comes across from one of your students, or from time to time in your studies.
So I haven't really thought about it too much. So, but I think being at all-female institution, it really makes a difference that there is actually a lot of power from women, and I'm always impressed what my students do in their free time, and how they push forward, have always good ideas and so forth. So you kind of feel this movement, I think. So I'm always very impressed about this.
And do you think there are more women that go into the geosciences?
Yeah, definitely.
These days compared to in prior history?
Yeah, I think so. And they even go in fields that probably in former times there might have been only men in those areas, like the mining industry or the oil industry or so. Now it's really women go into these fields, and so there's definitely a trend upwards, and I think the women are really needed. So there's actually a little bit of shortage of geologists in the world. So we need everybody to work on this. So.
That's interesting. So what's your class size usually? How many students do you have?
So it depends. So sometimes we have, so in our intro-level classes we can have up to 30 students or so, and but our upper-level classes are between 6 and 10 students, something like this. So it's actually a very small group, which makes it easier than if we want to do field trips and so forth.
Right. So. Excellent. So what are some of the classes that you'll be teaching this fall?
So this fall I'm teaching geomorphology. So this is everything on the surface processes on Earth. So everything on what we talked about the coastal development is very much incorporated in this. And and
do you teach an intro class as well?
Not this semester, but the next semester.
And those would be for non-science majors.
Exactly.
So they can have an introduction.
Exactly. So it is basically a mixed group. So it also our first year students in geology would take this class to get an overview of geology, and then they dive in deeper. So I read this article about how if women go into science, it's usually biology or biomedical research, and there aren't a lot of women to spare for other sciences. Yeah. And I always wonder why that is. And I wanted to ask you, what are your thoughts on why that is? Yeah, I'm also not 100% sure. And in our classes, we see often kind of an up and down. So some years we have a lot of students, some years a little less. So it might be that a lot of students have had biology maybe in high school, so they are a little bit more familiar with it than the earth sciences. So some students might not have had it. And so I think that might be a reason. We try to tell them so everybody should know a little bit how the Earth works.
Right.
So it's actually good to have an Earth science class.
Yeah, and it comes in handy because you live on the planet. So it's sort of that, behooves you to know what you're living on.
Exactly, yeah. And this is what we in my department, me and my colleagues, what we think, what we really want to get across, that we are responsible for the Earth and we should know how it works. So.
And where are some of the places that you're going to take your students out for field trips this semester?
Okay, so yesterday we were at Winthrop Beach. So you just got back into town like a week ago, and then now you're already on the road field tripping. Field trip, yeah. So this is something I still like to discover new places. So I also prefer to go out onto field trips with my students.
So once you're out, tell me how the anatomy of this field trip works. So you go out to the beach and you want to study coastal processes.
Yeah.
So how do you organize your students and say, okay, what do you have them do? Do you set up a grid pattern and say, give them different spots to cover? And what do you have them observe when they get out there?
So, and of course, we never do everything that I want to do.
But
so the
never enough time in a day.
Yeah, the time was too short. But we measured, we basically surveyed a beach profile. So they measured the topography of the beach using a surveying instrument that we call an automatic level. And then we basically plot all the storm events of the last few years on that profile and basically find out which parts of the coastline changed, because probably most changes happened during these extreme events.
And how do you spot storm events? So you're walking along this coastline, and for a layperson, how would they spot a storm event?
Well, so at Winthrop Beach you have actually a pretty so there was the storm of 1978 actually dramatically hit that coastline, and there is a so-called gravel washover, so really big pebbles are washed all to the top of the beach, and you can really see this. So you need quite some power to move these gravels all the way up there. And so that would be one feature that we would look at, and we see kind of these overwashed deposits.
So it looks like large pebbles engulfed by smaller grains of sand.
There's actually no sand there. It's really just the chunky gravels that are right there. So
interesting.
Yeah, so you can still see this, which is was described for the storm of 1978.
And that's so interesting, because a non-scientist who's walking around there wouldn't even think about what the implications for that.
This is true, yeah.
So now when people go out there, they'll say, oh, this is from 1978, I bet.
Exactly,
from the big storm that hit. Well, thank you. Thank you for telling us that. And how much of coastline do you cover? Do you walk a few miles to get information?
Well, our survey started basically at the coastline, and I told the students to go in the water as far as they could go, basically, and they were pretty dedicated. So they had their swim gear on and went a little further, and then we measured perpendicular to the shoreline. So we started in the water and then measured as far outwards. So we just did maybe probably 100-meter long profile across the shore. So, and each group did one of these. So,
well, and that would be definitely more fun to do, I think, in the tropics.
This is true.
Probably why you go to Sumatra, because the water there is so nice and warm.
This is true.
To the Atlantic Ocean out here.
That is true, even though the waves are pretty high there. So actually it was a little dangerous to swim in Sumatra.
So now I have a very non-geological question for you. So while you were in Indonesia, have you tried their coffee? Have you tried Kape Luwak?
Yes.
You have, and how is it? Is it everything that it's supposed to be?
Yeah, it was very special. Generally in that region, the coffee is very good. The coffee from Aceh, which is this northernmost province of Sumatra, is very famous. But the Luwak coffee is, of course, the most famous.
And how would you rate it compared to the other fine coffees that you've had?
Well, I must say I like the other one a little better. It has a very specific taste, so you have
to. It's a very distinct flavor.
Very distinct flavor, yeah.
That's good to know.
Yeah.
So for all of our viewers who are wondering about how this coffee is. Excellent. Well, do share with us, while we're wrapping up, do share with us some of your most other fun stories or your most embarrassing stories in geology. Either one, I'll give you the choice.
Yeah.
So tell us about some of the interesting things that you've come across while being a geologist.
Well, yeah, so I feel, so one thing that I feel passionate about is that we have to connect to people and to local authorities, especially in, for example, in Indonesia. We try to talk to the people there. We work together with the university there. And so, yeah, this last time when I was there, I had to give a talk to the local authorities about our work in the area and what implications there are. And so, so I started my talk, and there was a big group of people, and then suddenly, so at the beginning they were all listening, but suddenly everybody got really loud and was talking, and so, and I was wondering what was going on, but they came in with tea and coffee and little cakes.
Right. It was a coffee break time.
Exactly. No,
right.
This is their way of doing these talks. So you just make it a little bit more comfortable for the people who listen, that they have some coffee and tea available.
So did you stop talking and take a pause? And
no, I think I just continued. I had then also somebody who translated for me, so it was kind of, we both kind of continued, but at a slower pace probably.
That's excellent.
So, but yeah, it is just important to not just do science and leave it in the science world, but just to bring it to other people and try to reach out. So.
Oh, excellent. Well, I'll share with you an interesting geology story of mine.
Please.
So when I first started, I loved taking photographs. And so I was taking pictures of our group, of all the different people in our group, just as a keepsake, that we remember our field trip. And my professor came up to me and he grabbed the camera and he said, "What do you think you're doing?" And I said, "Well, I'm taking pictures of the other people in our group." And he said, and you're not taking pictures of the landscape or the rocks? And he says, you know what we do in geology, Rama. He said, we only take pictures of other people if we're using them for scale.
That is true, yeah.
So that was an interesting moment that stayed with me.
Yeah, yes. That is absolutely true.
So I think we have a few more minutes, and if you want to tell us about some other research projects that you're thinking of, upcoming stuff, please feel free to share. And
yeah, so as I said, the overarching theme of my research is looking for earthquakes and tsunamis in the geologic record. So, and in 1755 there was a strong earthquake here in the Boston area. It's the so-called Cape Ann earthquake, so a little further north.
And why do you think that was? Why did that happen, do you think?
Yeah, well, we still have some very, how can I say, you still, even though it's no more an so-called active plate boundary, we still have some old faults or basically fractures in the crust, and these can still move because we still have some certain stress field here. So we still can expect earthquakes here. They just happened at a very long time scale, and so in 1755 was the last one, but it was pretty damaging.
And the epicenter was in Boston?
A little bit further north, so Cape Ann.
Okay.
So this was the epicenter. And so now what I'm interested in, can we find sedimentary traces of that earthquake? And so of that earthquake and maybe of earlier earthquakes, so that you can determine the frequency of how often these strong earthquakes might happen. And so we are going out onto lakes and take sediment cores from the lake bottom and then analyze the sediment. So
and which lake are you planning to head out to?
So the one that I studied together with colleagues from Salem State University is Sluice Pond. So this is close to Salem, so north of Boston.
North of Boston. Oh, nice. So that's an upcoming project you have.
Yeah, and we have already a few.
Yeah, a few data sets from that. Oh, exciting.
Yeah.
Well, that's fascinating. That's great. Well, thank you so much for coming in today, and we'll have to have you come back maybe next semester and tell us about some of your findings from that.
Okay.
From that data set.
Definitely.
I'm sure people here would love to know when the next earthquake might occur. So.
Thank you very much.
Thank you, Katrin.